Hello everyone, welcome to day 18. Today I plan to do questions on this DSA pattern based sheet you see here. So many of the DSA questions are based on certain patterns, and if we are able to recognize which pattern it falls into, then it is easier to solve those questions. So I plan to do this sheet first. I'll start with this fast and slow pointer because we were working on a linked list earlier where I did a few questions on fast and slow pattern. So I'll start with these questions. Linked list cycle 2. Last time we did linked list cycle, it was the easy question. Now it's a different one. Given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. So basically, earlier we wrote the code to find to check if there is a cycle in the linked list, but now the question is that we need to find the starting point of that cycle. There is a cycle in the linked list if there is some node in the list that can be reached given again by continuously following the next pointer. Internally, POS is used to denote the index of the node that tail's next pointer is connected to 0th index. It is -1 if there is no cycle. Note that POS is not passed as a parameter. Okay. So in this case, this is the head of the linked list. In this case, this is the head of the linked list. One way of doing this would be that we take a hash map, and earlier to what we discussed, we take a hash map, and at each iteration we store the address or the pointer of that node in the hash map. And once we reach a point where we see that that pointer already exists in the hash map, then that is the starting of the linked list, the starting of the cycle. So for example, we will store 3, then 2, then 0, then -1, and once we'll reach 2, we'll check that at each step we'll check that if this node is present in the hash map, and once we reach 2, it is already present. That means this is the start of the linked list. That is one way, but it will take extra space. Other way of doing this is that similar to earlier question, we will take 2 pointers, one slow and fast, one slow pointer, one fast pointer. Slow pointer will move 1 step, fast will move 2 steps. So let's say this is the diagram, right? So slow and fast both initially will be here. Slow will reach 2 and fast will reach 0. Then slow will reach 0, fast will reach 2. Then slow will go to -4 and fast will be also reaching -4. So once we see that both slow and fast are equal, that means there is a cycle in the linked list. Now coming to finding the starting point of the cycle, so there is a mathematical formula. I've done this question before, so that is why I'm aware of this. Otherwise it's pretty difficult to come up with this. So what happens is, I'll show you. 3 1 2 3 4 5 6 7, and let's say 7 is connected to 4. Okay, so now 7 is connected to 4. Okay, so just imagine that there is a cycle from here to 4, 7 to 4. It is difficult to show it here. I won't be able to explain it like this. Let's take this diagram and I'll explain it from the diagram itself. So let's say slow is moving. First of all, I'll quickly write the code, or I'll do it later. So first of all, we need to find the cycle in the linked list. For that, slow will be at 3. By 3 I mean the this node, and fast will be also at 3, right? Now we know that slow is moving 1 step and fast is moving 2 steps, right? So that means that once slow and fast are equal, at that point, if slow has moved x distance, then fast must have moved 2x distance, because fast is moving with twice speed, right? So if as we saw, -4 is the place where slow and fast are meeting when we are detecting the cycle. So if slow is moving till here, so if this distance is x, then fast is moving like this, then this total distance is 2x, right? I'll repeat, if this distance is x, then this distance is 2x. What does that mean? That means that if we subtract this distance from this distance, that will give us the distance of this cycle, because fast pointer has moved how much extra? It has moved one cycle extra than slow pointer. That means this length of this cycle is also x, right? So this is also x, slow has moved this distance, this is also x, and the length of this cycle is also x, right? Till here we got it. Now slow and fast are here, and we are saying this distance is x, okay? And we are saying that this distance is also x. So what is common? This is common between both. Between this distance and this distance, this is common. So if we remove this, then that means this distance and this distance is common. I hope you are catching up with me. So this is equal to this. So with this formula we can come up with this index. What I'm trying to say is that we already know the slow is here, and if we keep a pointer at the starting of the node, starting of the linked list, and if we move both of them simultaneously, then both the pointers, the first pointer which is at starting and the end pointer, both will reach the start of the cycle at the same time, and that will be the result. I won't be able to explain it again, but I hope you got it. If you want, I can explain it in some other video. Let me know in the comments. So I'll write the code for it. So what I'm saying is, first of all, we'll detect the cycle. For that, I'll take a list node, slow as head, and list node, fast is also head. Now while fast is not equals to null and fast dot next is not equals to null, we'll move slow as slow dot next and fast as fast dot next, which means 2 steps. And we can check if slow is equals to fast, that means we have detected the cycle, so we will break. Okay, is it possible that cycle is not there? The number of nodes is this, -1 valid. If there is no cycle, okay, it is possible that there is no cycle. It is -1 if there is no cycle, okay. So to detect a cycle, or fast dot next equals to null, that means there is no cycle, then we'll return -1. Now once we have detected the cycle, we need one pointer which will represent the head. So let's update slow equals to head, and fast is now here and slow is at the start. Now while slow, and we also need a int result equals to 0 to count the indexes, while slow is not equals to fast, we'll update both. So slow equals to slow dot next and fast equals to fast dot next until they meet, and will return result, and we'll update also result plus plus to update the indexes. I think this should work. Let me run the code. List node, return list node. There's tell it is -1 if there is no cycle. What I'm supposed to return? There is a cycle node. The pause is not passed as a parameter. Reach to continuously internally pauses to need the index of node. What I'm supposed to return? The index, the node itself. Okay, so return null here. Then we don't need result, and we can return slow or fast, any one of these. Good, I'll submit it. This is done. The time complexity in this case will be order of n. I'll close this. Next is remove nth node from the end. Okay, given the head of the linked list, remove the nth node from the end of the list and return its head. Okay, so the brute force approach would be that we traverse this whole linked list and we find the size of that linked list. Okay, so let's say we have the list as this, and once we'll traverse, we'll get that the size of this linked list is 5. After getting the size, then we will find the size minus nth node. So 5 minus 2 is 3, so third node, right? Second, third node plus 1, 1, 2, 3 plus 1th node. Okay, so brute force approach is that we need to go through the whole linked list once. We find the size of the linked list and then we can iterate and again find the nth node from the end. That is one way, but they're saying could you do this in one pass? So in order to do this in one pass, what does that mean is that we need to traverse this whole linked list only once. We cannot traverse the whole linked list and find the length and then do it. We can traverse only once. So for that, what we can do, so if we take 2 pointers, slow and fast, I don't think it will work. If both the pointers are here, how we will find the nth node from the end, that too from the end. If it is from the start, if they say that we need to find the nth node from the start, okay, so that we can do. We will and that is straightforward what I'm thinking. Okay, fine, it is from the end. So if we take what if I move the fast pointer n times and slow only one time? So if fast is, so initially both are at 1, fast will go to it needs to move 2 pointers, so 1 2 here, and slow will be at 2. Then fast will go to 5 and slow will be at 3. I don't think it will work. Let me take a bigger example. 2 3 4 5 6 7 8 9, and let's say we need to return the fourth. Okay, fourth, so 6, we need to return the fourth node from the end. So for that, if I move the slow pointer, both slow and fast are initially at 1. If I move the fast pointer 4 times, so 1 2 3 4. Including this or not including this, if we do so, if it will be here and fast will be at 2, then if we move this 4 times, 1 2 3 4, fast will be at 3. No, this will not work. What if okay, what if we move the fast pointer 4 till 4 length, okay, and we'll keep track of the earlier one. So what I mean is that once, let's say fast reaches here 7, so we know that we cannot move 4 pointers ahead, 4 nodes ahead, because there are no 4 pointers. That means the answer will be in the previous, somewhere in the previous node, from the previous node. In that case, we'll keep track of the previous, let's say fast was here earlier, then we'll keep track of this and update fast 4 pointers. So let's say slow is at 1 initially, fast is at 1, okay. Now we'll update fast, but we'll keep track of slow. So will not move slow. Fast will be 1 2 3 4, so fast will reach 4, and we are counting this index. Well, this is 4, okay, and slow will remain same. Then slow will remain same, because we don't, what if there is no so answer will be somewhere here, okay. Slow will remain same. Then we'll move fast again 4 pointers. So fast will move 1 2 3 4, fast will be at 7, and slow will come at 4. Now slow will get updated. Then fast will be, then again we'll move fast, and we can see that we cannot move ahead. So we can check how many pointers are there from here to here, how many nodes are there, and then slow is here, so accordingly we can move slow and get the result. I think this should work. So if fast is here, then we'll know that there are 3 nodes here and we need only 1, and there are 4 nodes here. So we need to move 3 ahead only. Got it. But we don't need to move it for the first time. So initially we can do like this. Let's take list node slow at head, okay, and list node fast is also at head, and initially let's move fast till 4 pointers. So int count equals to 1, while fast dot next is not equals to null, we'll do fast equals to fast dot next, and we'll do count plus plus. Now we know that fast has reached here, okay, and we also need to check what if fast already reached the end, then we'll have to update accordingly. But for now let's keep track of this. I'll write that code later. And now what we need to do is, so slow is here and fast is here, so then we'll write while again, while fast dot next is not equals to null, and let's take list node temp equals to fast. Then we'll keep updating it, and let's take count equals to 1, or we can take count equals to 1 here. Count equals to 1. Count equals to 1 initially. Then we can update fast equals to fast dot next count plus plus, and if count equals to 4, we can check this initially. If count is 4, that means we have reached that index, so we can update slow equals to fast, and count equals to 1. And if we reach the end, then we'll update slow. So while count minus count is greater than 0, slow equals to slow dot next, okay, and count minus and return slow. For now, one thing is missing here is that if fast dot next equals to null, in that case we'll have to do this. Let me try to dry run this. Initially slow is at 1 and fast is at 1. Fast is at 1, count is 1, okay. Now we are running till fast is not equals to null, so fast will become 2 and count will become 2, and count is less than n, because we need to run it only there, so we need to run it only 2 times. That's all. Fast will be at 2 and count will be 2. That's all till here. Now this will be fine. This fast dot next is not null. Then we have temp equals to fast, so we have a variable temp equals to temp will be at 2. Here I think it will be temp. Temp is at fast and count is 1. Now again fast is not equals to null. If count is 4, count is not 4, so fast equals to fast dot next. Fast will become 3 and count will become 2. And then why I'm checking with 4, it is n. So now in next iteration count is 2, count is n, so slow will become temp, slow will become 2, slow will become 2 and count will become 1 and temp will become fast, will become 3. Now fast plus plus, so fast will be 4, count will become 2, count will become 2 and then again we are back in this. So slow will become temp, slow is, how come fast is 4, right? Slow will become temp, temp will become fast and count is 1. Now again fast and fast is 5 and count is 2. So in this case count is n, slow will become temp, slow will become 4, temp will become fast and count will be 1. Now wait a second, this will not run because at this stage it will break because slow is at 3, temp is at 4, we are already at the last index 5, so in null it will break out, count is greater than 0, slow equals to slow dot next, slow is at 3. Oh, am I supposed to delete this node? Remove the nth node. What am I doing? I need to remove the nth node. This will not work because I was trying to find the nth node. Now if I'm at the nth node, then I won't be able to delete it. I'll need to do one pass again to delete it. In that case, I think if we want to reach here, let me try one more thing. I think this is getting complicated. So if this example is not good, if let's say 5, 6, 7 and 8. Okay, now let's say what if I move the fast pointer ahead n steps and then move both the pointers, because this we need to. So what I'm saying is, initially we are at this point, and if we want to remove this 6, I get it. So what we'll do is, we'll take 2 pointers and move the fast pointer ahead till n steps. N is, in case let's say n is 3. N is 3, okay. So we'll move the fast pointer till 3 steps. 1, 2, 3. So n will be reaching 3. Fast will reach 3 initially. Now what we'll do, we'll take slow at head, so slow will be at 1, and now we'll move both the pointers together. So what will happen, once the fast pointer reaches the end, slow will reach the nth from the end. So fast will be at 4, then slow will be at 2, fast will be at 5, then slow will be at 3, fast will be at 6, slow will be at 4, then 7, then 5, then 8, then 6. But one thing is, we need to stop before 6 if we want to delete it. So 1, 2, 3. So in such case, you also need to keep track of previous pointer of slow. Because if we reach 6, we won't be able to delete 6, so we need to keep track of 5 as well. I'll write everything again one more time. So let's say initially list node slow will be at head, and list node fast will be also at head. Now for int I equals to 0, I is less than n, I plus plus, will move fast, so fast will be fast dot next. I think we should take it from 1, because so initially at, if I is 0, fast will be at 1, then fast plus plus, fast will become 2, I is 1, fast will become 3, I is 2, fast will become 4, fast will become 4, and I, what if I move one step ahead, then I think will be, then we'll move together to 3, 4, 5. I think this is a good approach. Let's keep this. And then what we'll do is what if it reaches the end? What I mean is, let's say if it is saying the 8th node from the end, okay, it is saying, asking us to return the 8th node from the end, then it will be 1. Okay, so once we'll start moving, fast will reach the end. Fast will reach the end. That means 1 is the result. So if we need to remove 1, again I'm forgetting that we need to remove. So if fast is null, that means we need to remove the head. So result will be head equals to head dot next and return head. Now the next case. So what I was doing, so fast has reached here. So now we will write the code. While fast is not equals to null, slow equals to slow dot next and fast equals to fast dot next, and then we need to remove slow. So slow is here. Slow dot next equals to slow dot next and return head. Let me try to dry run this once. We'll dry run the same example. So slow is at 1 initially, fast is at 1. Now in this for loop, fast will be 2 when I is 2, then fast will be 3 and I is 3. Fast will reach 3. Fast will become 4 and then I is 3. Now this will break. So fast is 4. Okay, fast is 4. Now we have slow here and fast here. We'll move both together. So slow will become 2, fast will become 5, then slow will become 3, fast is 6, slow is 4, fast is 7, slow is 5, fast is 8. Slow is 5, fast is 8. We need to stop at 5. We don't need to go till 6. So this will not be this, but rather fast dot next is not equals to null. Till then we'll run. I think this is good now. I'll submit it. I'll try to run it first. Submit. Okay, this is done. So in this the time complexity is order of n, and also we did it in one pass. Let me see the solutions, one or two solutions. Instead of calculating the total length of the linked list, we can use a smarter trick. Maintain a fixed gap of n between two pointers. One pointer ahead moves n steps ahead, the other pointer stays at the start. Now ahead reaches the end temple just before the node v in. ठीक है. Given an array of integer nums containing n plus 1 integer where each integer is in the range 1 to n inclusive, there is only one repeated number in nums. Return the repeated number. Given an array of integer nums containing n plus 1 integers where each integer is in range 1 to n, there is only one repeated number in nums. Return this repeated number. You must solve the problem without modifying the array and using only constant extra space. This 3 is repeated in this. What is this? Okay, it can be repeated any number of times. All numbers are only ones except that which is multiple times. I'll do this question tomorrow. I think